So welcome again to the DS Incubator. This time is with a one session meetup. It's not a series. That was motivated by a conversation with Miria about running Python code from RStudio. Why that might be important for us or for anyone like us that has a team of data scientists that work with both R and Python. And well, the reason is because each language has kind of preferred tools, preferred IDEs, graphical user interfaces, like for R, for example, RStudio. And in at 2 degrees where we work, a lot of us actually are familiar with R and familiar with RStudio, but occasionally we prefer to work with Python. And then the change in the language is itself a challenge. On top of that, if we have to change IDEs, the graphical user interface that we use to interact with the language, that's another layer of friction. And sometimes you want to run code in 2 languages in the same report. So how do you do that? For us, we kind of are more familiar with R with Python. So we're gonna be talking today about how to work with Python code from RStudio. So we're gonna make the choice of working with RStudio and then seeing how we can actually run Python code. So it's as usual, there is a repo dedicated to usually it's a series, but this time it's just one meetup. Here in the repo, usually there is one folder per meetup. So let's do just that. The folder is this one, 01, the demo. So we're gonna get, if I can get in there. Well, actually I have it here on my directly on, I downloaded or cloned the repo locally, and it has that folder that I mentioned before, 01, and here there is the materials of the day. The README file, which I'm gonna need right now, is a combination of R and Python code, and the Python code is realistic. It's kind of small but realistic in that it has some complexities that sometimes cause friction. For example, we need for this code, we need some packages, some Python packages that are not super smoothly sometimes to install. So let's walk through the contents of today little by little. So here we are in RStudio, and I'm gonna very quickly scroll down to the code that motivated the meetup. Here is a little bit of Python code here in the example. It doesn't really matter for the meetup what it does. What it matters is that it actually runs. So the output that you see here proves that this code has run. And as you can see, I'm running this from RStudio, so we kind of achieved the mission. And at the top of this, I also ran intentionally a little bit of our code. So that is to show that in RStudio we can use, for example, R Markdown documents to intermingle in the same report both R and Python code. So the rest of the meetup is going to be talking about my personal experience learning how to do this. Telling you about what tools I discovered that kind of come out of the box or work automatically to enable this interface between Python and R, and which points I felt the most friction and where I still have huge gaps in my knowledge that are probably the places where I should kind of invest some time because learning those, more about those gaps could reduce the friction in general. So to begin with, RStudio by default, or R Markdown, which is a package inside R, that is the one that I'm using to create this report with Python and R. Both of those tools don't just work by default. You have to install a package called Reticulate. So Reticulate is an R package. This is the the address of the package. So I'm going to show you what that looks like. Let's scroll here. If I click here, I should go to a web browser. There we go. So this is what the website of the package looks like. So a lot of the tools that enable this communication between R and Python work smoothly once you install the package. But if you have a completely fresh computer with R, you install RStudio, you install R Markdown, you want to knit an R Markdown file like the one that I was showing just before, you will get an error. It will be a very informative error. It will tell you that you need to install Reticulate. So that's simply what you do is you just install Reticulate as you would normally do with install.packages, the name of the package Reticulate, and you're good to start working with it. And then a very simple code would just run in R Markdown. The code and the prose is differentiated by chunks, right? So you can write prose like this, or you can write code like this. So the code, for example, in this case, I'm running R code in R Markdown is running in these chunks that are defined by this weird kind of little format. But if it says R, it's going to be an R. It's going to expect R code. But you can also use the engine Python. So once you install the Reticulate package, then R Markdown will understand this thing. So instead of saying R here, what you say is Python. So if you say Python, then it will expect Python code and it will just work. Quote, quote, just work. Because then there is probably the biggest source of friction, which is the idea of where Python comes from, where the packages come from, where all those things are installed in your system, and how RStudio is going to discover them to make that script run. So what I'm showing you here is the successful attempt, but before I got here, I struggled for hours trying to understand what was going on. And what I did here is use the code that Miria gave me as a challenge to see if I could run it as vanilla as possible, and only in only one little tweak I had to do. So let me kind of walk you through. Sorry for this, is very unstructured because because it didn't have a lot of time to prepare. I was mostly kind of struggling with trying to get this to run. So yeah, just it's kind of a story of frustrations and success. So let's go to. So by knitting this document, I show that code works in R Markdown, but you may also wonder, okay, what happens if I want to run that code like as Python code directly? So apart from talking about how to run it in R Markdown, I would like to talk about, okay, what if you only have Python code? You can create a file that is a Python file, Python script, just basically a file with the extension .py and py, and there you can just stick the same code in this case that I have in the Python chunk. So let's go back to the R Markdown. So this is the chunk, and the same code is here. And if I source the script, you will see a couple of things happening magically. So let me restart my R session to show everything and clear this up. So when you run Python code as you would normally do with R code, which is basically what you do, you stand on a line, press Ctrl, hit Enter, and you send code to the console. In R, the code will just run. When the code is Python, then the Reticulate package, which I told you was the back end of this interface between Python and R, will automatically print this code. So this is code that I did not type. Just by sending the Python code to the console, RStudio detected via the package Reticulate that is Python code, and then it turned the R console, which usually has this single greater than symbol prompt, it turned it into a Python console. So now what's running here is Python code. So I'm gonna keep pressing Control and Enter to show that I can run each of those pieces of code interactively. So not only you can work from inside RStudio and run our code in our Markdown documents, but also you can do it interactively on a console, on a Python console that will automatically be launched by the Reticulate package once you install it. Here, I wanted to make a mention that this specific piece of code was extremely problematic. The reasons are maybe not super important to discuss, because this is a very specific piece of code. So if you're trying to do this with your own code, maybe you won't need to install this specific, module or model, I think. But in this particular case, the challenge was that the normal ways to install packages, Python packages, of which I'm going to be talking about in a moment, did not just work. I had to install this specific model that apparently comes from the Spacey package. So maybe Miria in the section of comments and questions can extend on why what might be the case. So I keep running this code. Now I'm gonna print that, and finally, so this actually doesn't run interactively like this, but if I source it, it does print the output. I don't know why interactively I could not print, honestly, but sourcing the script does the job. Okay, so we have run the code interactively. We have sourced actually the code as a script. I don't know why it did not work. The print here when I work interactively, it did work. The print when I sourced the script, and we did it also in our Markdown. Now let me tell you what things I found most challenging. So mostly what I found more complicated was the idea of, okay, where Python is installed in my system, which Python it's gonna be used by RStudio, and then not only that, but also the packages. So in R, you install packages directly from R itself with something like install packages, and when you install R, you install it not from R itself, you install it like differently, but usually you have only one version of R. So you may have more, but it's kind of rare. In Python, the situation is a little different. There is, to begin with, like two main distributions of Python, like almost two versions that are that people still use. And even within that, Python kind of encourages the idea of working with specific environments for specific projects. So you may be using in one project one version of Python, and in a different project a different one. So you have to somehow tell, in this case, RStudio, which version of Python you want to work with. So that was the first challenge. The second challenge is the packages, right? So in R, we use a lot a main repository called cran. In Python, there is more than one place where packages can come from. In R as well, but it's very common that you will only install from cran or a cran mirror, something that is very similar to cran, and the packages are associated to a version, and you usually don't need to know very much where they live. They just kind of happen that another version is associated to all the packages that of that version. In Python, again, because it encourages the idea of environments that are kind of project specific, usually you would have a project associated to one version of Python and to a collection of packages that are dedicated to that project, and a different project may have a different collection of packages. So that idea actually is pretty cool for data science because it makes your data science reproducible, and it is an idea that R has been kind of working on very intensively, and is the idea that has been kind of implemented in the package renv, which creates little environments that are totally insulated from other projects or other kind of R environments. So you are you know exactly which packages you use. So that idea in Python is also very well developed, but also adds complexity, right? So it's great because when you have everything working, you have the ability to reproduce your scripts efficiently, but managing all of that is super complicated. So to, I think, kind of address that issue, Python has developed, there is a project in Python that is called Anaconda that itself is a distribution of the software of different kinds. On the one hand, it contains Python itself. It also distributes R and RStudio if you want to, and it also contains a collection of more than, I think, 7,500 packages, Python packages. So you may want to install that distribution called Anaconda, which brings a lot of tools that are very useful and very common apparently in data science with Python. For smaller projects, maybe that's an overkill and you may not want to install so much stuff, but it looks like it's a very well maintained project and very smoothly. So in my conversation with Miria, she recommended it and she said that her experience with Anaconda was fairly smooth. So that's actually when I tried to install packages from different sources, when I did it with Anaconda, it was when I had the most success. So for example, Anaconda, which I'm going to click here to kind of introduce you to the website. Here it is. It has instructions to install it, and it explains all that you might want to know about Anaconda. So Anaconda is, already contains, for example, these two packages that the example script needed. So they were already by default there. I didn't have to kind of do much more than that. But then again, when it came to running, where is that line of code? Here. When it came to running this line of code, which still I don't fully understand, this failed. So I had to install with a tool called Conda that comes with Anaconda. I had to install this component here, which wasn't available before. So I'm gonna wrap up here because I don't have a lot of knowledge. All I can share is my experience. Sorry, there's this one super important thing that I wanted to tell you is that before I finish, that so I mentioned that it's very one big challenge is to identify where Python comes from and where all the packages go. So that is something that you can specify in many ways with the package Reticulate. And one way that kind of overrides every other way is to use an environment variable called Reticulate_Python. So if you tell, if you set in that environment variable, which is the Python binary that you will be using, then the entire script or the entire in this case, the environment variable is set only for this project, but you could do it at the level of your system. So in this case, it's clear that is the one version of Python that you want to use. So in this case, I chose to create an R environment file in this project to set the location to the Python version that comes with Anaconda. So after I installed Anaconda, I realized that it was installed here under my home directory under the folder Anaconda 3, and there is Python. So with that, it's clear. RStudio will know that Python is there, and it's gonna. I didn't mess up with environment, but Reticulate has a bunch of really good tools for, let me show you a help file, install Python has a bunch of very good tools to manage those environments. So you can tell, in this case, your scripts. You could use functions to install a specific version of Python, and you can use environment. So this chunk of code here here, where it says library reticulate version. So allows you to specify versions of Python, allows you to create virtual environments, which are these sandboxes where you can put the Python and you can put the packages, and then you use that environment in your project. So that's very, very, very similar to how RM works. But, and that's the big but, when I try to do this, which could be kind of the best practice if you want to use like all the features of Reticulate, I failed. So the simplest way I had success with this script was simply setting this environment variable and letting basically my system install the packages wherever they want. But because Anaconda comes already with the packages, I didn't need to worry about that. The only one package that I had to install was that one that I mentioned before, this model from Spicy, apparently. So I'm going to leave it at that. I'm going to go back to the meeting room and see, hopefully Miria has some experiences that she wants to share as well with us, maybe about your successes and frictions.
Actually, all I want to do is say thank you, because I think the problem that I had really was forcing the Reticulate Python path to look at my Anaconda distribution. So that was the point where I failed when trying to use RStudio. And this seems to be solved. So thanks very much.
Okay, so say that one again. So you did or you did not set the path to your Anaconda distribution?
I failed at exactly that step, and that is why I couldn't make it work.
Okay, good.
Now it will all be a bliss.
Great, yeah. I think that, for people like us who have a lot of experience working with code, and when something feels that there is a lot of friction, I think that, of course, I feel the pain and I put that on my shoulders, but I think that maybe there is still like some tooling or some documentation that needs to be enhanced so that people with experience don't struggle like me like for hours to get like one script running. Anaconda is great in that it seems to be like the one place where you just install it and then it just works. But still, I feel that RStudio is making a great work in allowing all of that to come into RStudio, but obviously, at least in my experience, it's still not there. I mean, there is a little bit more friction that needs to be polished before I feel that this is something that I would kind of recommend to people. But this is only like, my experience with this has been like only a few hours, say 3-4 hours put into understanding all of this. Usually that's not too much. But I would have loved to just get it working in 10 minutes, not 3-4 hours. Do you have any idea, Miria, about this one spicy model Core Web SM? Why was that? So I don't fully understand the Conda installation tool. So I know that if I do Conda install, for example, package ABC, it installs package ABC. But I don't understand what it is, Conda Forge. Do you have any idea? I'm just very curious.
Maybe a quick correction. So this should not be a package, but a language module that is within the Spicy package. But I don't know the Conda Forge specification.
Okay. I see that Reticulate has a function that allows you to also install Reticulate. For example, if I do Conda, so there's two types of environments that Reticulate supports. One is Conda, so there is a collection of functions like Conda install, for example, and it has a Forge argument here, and it's set to true. But I wasn't successful in specifying, this model. When I tried to install it this way, it failed. And then apart from Conda, there is, I think there is virtual env, another set of tools also install. So this is how you would use basically Reticulate to install Python packages from inside R. If you are not doing that, like in Python, there is no, at least not that I know, there is no way to install Python packages from Python itself. What you would do is you would go to a terminal and do something like Conda install or pip install. But no, you don't do that from the Python console. You do it from a normal shell. But Reticulate does provide that feature so that you could do it, but I failed. I think virtual env uses pip, and I think that Conda uses Conda as two places where packages come from, the two main repositories apparently of Python packages. So, by the way, sorry if some of these doesn't make a lot of sense, or I'm saying things that are wrong. I'm super new to Python and new to using Python from RStudio, so be kind. I'm just learning. Anything else, Miria, that you would like to comment or share?
No, thank you.
No. All right, then we'll wrap it up here. It's exactly half hour. So thanks, Miria, for motivating this meetup and for sharing the code. That was a very interesting challenge. I would say that I learned a lot, but not enough to feel that I understand everything that's happening here. So if you continue to have friction, Miria, let me know, because I'm interested in understanding this a bit more. I already invested some time kind of in getting like, I feel that I'm like 70% there, and I would love to have another push to get all the way to the end. So keep in touch and share your successes and frustrations with me. Thank you for now. See you next time.
Thank you. Bye bye.
Ciao, ciao.